All right, so warm-up number 9. Once again, number 1 says simplify. Number 2 and 3 is to solve. Should be just about done. I'll give you one more minute. Those of you that are done, make sure you go to Canvas, turn in last night's home play. Did I open the assignment? I haven't opened it yet? All right, then hold on to that. Get a Cornell note ready instead, and I'll give you a little bit more time for that. All right, so let's go over that warm-up. So let's get this show on the road. All right, tell your neighbor what you got for number 1, and then Maya, our coach, is going to give us that answer for number 1. All right, what'd you get for that one, Maya? Minus 3 plus what? 7x. All right. Hands if you got that in any order, Okay, looks about right. However, in standard form, here it goes again. You check for exponents on variables. This is 1 because it's invisible. Since they have the same degree, that means we write them in alphabetical order. So we start with what? 7x, then 4y, and at the end, the constant, which is the number without the variable. Okay? Number 2. What'd you get for number 2? I just need the answer. Tell your neighbor before Maya passes it to someone. All right, Maya, pass someone. Desley. M, what else? Less than? Negative 9. Hands if you got that? That is correct. Tell your neighbor why this flipped. Why did that flip? Yeah, because we're divided by a negative, yes? All right, last but not least, number 3. Tell your neighbor your answer for number 3, then we'll pass it to someone. All right, pass someone, Jocelyn. Courtney Jean, what'd you get? Negative 1 over 3. Hands if you got that, or negative 0.3 bar. Yes? Looks about right. All right. Copy the agenda, please. Warm up number 9, absolute value equations and inequalities. We're moving on. We're still on one variable equation and inequalities, but we're moving on to absolute value. And then we got play sheet number 10 tonight for home play. So, Nearpod code RDEJZ, or you can go to Canvas and get the play sheet from in there. All right. So there's last night's. You turned that in already, yes? And we did a lot better with this, yes? All right. And we're moving on to absolute value. Yeah, let's go. I love these. These are good. All right. So, again, the intro was about keeping it balanced, yes? And we are in one variable equations and inequalities. I can solve one variable equations and inequalities. We do not need a fair model since we already know what they are. So without looking at your notes, tell your neighbor the definition for one variable equations and inequalities. Yeah, some of you are like, man, Mr. Hugh, you've been hammering us with the definition. Yeah, because I want you to understand where we're at. Yeah, so we said that they are expressions that are equal or not equal to each other. These are the examples. Non-examples came up with hashtags. Do we know the steps? Yes. Simplify, isolate, plot, check. Simplify, isolate, plot, check. Simplify, isolate, plot, check. Simplify, isolate, plot, check. Okay, we got that. However, today we're doing a very special type of equation known as absolute value. So I want you to copy these next steps that we need to use for that. Copy these. Step number 1, isolate the absolute value by using inverse operations. And once again, what does the word isolate mean? To leave it by itself on one side of the equation. Step 2, write 2 equations without absolute values. That's the next step. And last but not least, solve each equation. Solve each equation. Copy that. I'm going to pause the music for a little bit just so that we can understand the intro to absolute values. Okay? Writing utensils down. You can copy that later. You have the Nearpod code. Eyes on the screen. Here goes a quick intro. Ready? What are absolute values? You've covered this before, hopefully. But here it goes again to remind you. Absolute values. Look up. Absolute value. What is it? The distance of a number away from 0. 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 Those are the symbols. What is the absolute value? The distance of what is the absolute? The distance of a number away from 0. Those are the symbols. What is the absolute value? The distance of the distance of a number away from 0. Am I making it kind of obvious? Yes? So what is the absolute value? The distance of a number away from 0. The distance of a number away from 0. Now, check this out. Have anybody asked why we use those bars for the absolute value? No? Here it goes. Here's 0, and here's a number. You're like, what? Here's 0, this bar right here, and here's the other number. The distance between 0 and that number is the absolute value. That's why we use those symbols. So, any questions to what absolute value is? No, pretty obvious, yes? All right. Just in case, oh my goodness. Hold on. Sometimes just the, you know what I'm saying? All right. So, here it goes. Look up to the screen. Absolute value. Question. What is the distance of negative 23 away from 0? Notice how he made it like take little steps. How many steps? Did we say negative 23? No, it's a positive value. So it doesn't matter which way I go, either one direction or the other, it's still a positive 23. So, another way of saying it, what is the absolute value of negative 23? And if I use symbols, here it is. What is the absolute value of negative 23? And what was it? Yeah, look at my animation. Let's go. Pretty good? Be nice, Rebecca. All right. So, with that said, look up to the screen. If I was to ask, what number is 23 steps away from 0? Think about it. What number is 23 steps away from 0? Tell your neighbor, please. What number is 23 steps away from 0? Who said negative 23? Who said positive 23? That is correct. Both of those are 23 steps away from 0. Another way of saying this is this. Absolute value of x equal to 23, which means what number is the distance away from 0. How many distance? 23 steps away from 0. So therefore, the distance will be, check this out, look up to the screen, x is negative 23 or x is positive 23, because there's how many distances? Both of those numbers. Are we there so far? All right. So with that said, that was a good intro. Are you guys remembering these, some of you? Copy this one, example 1a. It says, solve the equation, absolute value of x minus 3 equals 23 microjoules. Solve the equation, absolute value of x minus 3 equals 23. So, line down the equal sign. We're going to do this one together. We're going to start slow. Step 1 says, isolate the absolute value. That means we need to leave the absolute value by itself. What's next to the absolute value? Negative 3, so we use inverse operation. So what do? Plus 3 plus 3. We're left with absolute value of x equals 26. Stop messing with the computers. Focus. Are we there? Okay, here it goes again. Step 1 says to leave the absolute value by itself. If you don't see it, you circle the absolute value, and anything that's outside of it on that side of the equation, you get rid of. So what's outside? The minus 3. So what is the inverse? We add 3. We bring down the absolute value of x down here, and now we are here. Is the absolute value by itself now on one side of the equation? Yeah, so we're done with step 1, isolate. Step 2, it says, write two equations without the absolute value symbols using this. Watch. Before you copy, look up, please. I'm going to write two equations. One that says x equals, this becomes a what? Negative 26, and the other one is x equals positive 26. Why? Because we have two numbers away from, yes, that is correct. Copy that. We're going to make one equation negative, the other one positive. So if you notice, I rewrote this. Let me highlight it so you guys can see it. I rewrote this twice without absolute values, but one what? Negative, and the other one positive. Did we solve? Can we solve anything else? No, we're done. That one's already solved. All right? From 1 to 5, how comfortable are you up to right there? Okay. 23, all right. Okay, copy this next one, please. Example 1b. Example 1b. It says, solve the equation 8 equals absolute value x minus 2.5. Line down the equal sign. Let's do this one together. It says, isolate the absolute value. So circle the absolute value. Here's one bar, here's the other, so I'm going to circle the whole thing. Is there anything outside that side of the equation of the absolute value? No, so we're done with step 1. You're like, what? How about the negative? That's inside the absolute value. I'm talking about outside the absolute. Is there anything outside the absolute value? No. Okay. Next, we write what? Two equations. So one of them, we rewrite the whole thing. Watch. I'm going to write it exactly the same. 8 equals x minus 2.5. 8 equals x minus 2.5. Do you see that they're two exact the same equations? Yes? However, one of them has to be the negative 8. The other one has to be the what? Positive 8. There it is. So what's the only thing that changed? Just the number by itself, one of them negative and the other one positive. We're done with step 2. Let's go to step 3. What does it say? Solve each equation. So line down the equal sign here. What do I do to solve this equation, everyone? plus 2.5 plus 2.5. We end up with negative 5.5 equals x. I'm going to go to the other side. I'm going to do the other side in red. Here it goes. Plus 2.5 plus 2.5. And we're left with 10.5 equals x. Are we done? Yes, from 1 to 5, how comfortable are you up to right there? Yeah? Okay. Now, just to crank it up just a tiny bit, let's write a solution set right here in the middle. Solution set. What is my first solution? The negative one. Negative 5.5, comma. What is my other solution? 10.5. And you close that. As long as you give me that, that's fine. That's how you write the solution set. Solution set. All right. Not bad. Yes? All right. So, give me a second. Send me your notes, please, on that one. All right. Example Q, copy that. It says solve the equation 2 times, so when it's in front of the absolute value, it's multiplying. 2 times absolute value of x plus 4, close the absolute value, minus 1 equals 11. I'm going to pause the music. We're going to go over this one together. Here it goes. Line down the equal sign. Where's the absolute value? On the left side. I want you to circle the absolute value. I'm going to do that in red to remind me that I need to leave that by itself. What's outside the absolute value there? The subtraction and the multiplication. What is it? Subtraction and multiplication. So let's start with subtraction. What is the inverse? Plus 1, do that to both sides. Bring down the rest. What was left? 2 times x plus 4, absolute value equals 12. How do we cancel or get rid of that 2 that's multiplying, everyone? Divide. We divide by 2, both sides. Now, in this case, why didn't I distribute? Because this is not a parentheses. It's an absolute value, and we're leaving that by itself. So, we're left with absolute value x plus 4 equals 6. Do we have the absolute value by itself already? Yes, so we're done with step 1. Let's go to step 2. What do we write? 2 equations without the absolute value. So x plus 4 equals 6. X plus 4 equals 6. However, this has to be what? Negative. So we change the 6 to negative. And this one stays positive. So we're done with step 2. And what is our last step, everyone? Solve each equation. So I'm going to do the left one in blue, the right one in red. So, Noah, what do we do here? Subtract 4 from each side, so we end up with x equals negative 10. How about over here, Noah? Subtract as well. X equals 2. Am I done? Solution set, negative 10, comma, 2. From 1 to 5, how comfortable are you with these? Yeah, we got this, yeah? Let's go. And tomorrow's Friday? Come on now. Somebody. Tomorrow's Friday. Let's go. Yeah? Remind your neighbor what's going on tomorrow. They're like, picture day? Makeups for pictures? No? And never mind. All right, let's see how you do with this. Oh, actually send me your work. Hold on. Let me Send me your work for that one. See what you did. As soon as you're done with that one, copy this one on the screen. See if you can do that one completely by yourself. And it reads, example super Q. Solve the equation 3 times x minus 2 absolute value plus 5 equals 11. Copy and go. So, who did we say was going to help us out with the process? Brandon, Felix, let's go. All right, hold on. Let me help you out. There you go. All right, go. Subtract 5 from each side. We end up with 3 times the absolute value x minus 2 equal to 6. Hands, if you got it to right there. So far, so good. Continue, Brandon. Divide by 3 both sides. We end up with absolute value x minus 2 equals 2. All right. What do we do from there? Tell your neighbor, and then Brandon's going to pass it to someone. Pass someone, Brandon. X minus 2 equals 2. And what else? X minus 2 equals 2. So 2 equations. Very good. But one of them has to be what? Negative. There it is. Hands, have you got that? All right. Continue, Martin. Plus 2 on both sides. So x equals 0. And then this one as well, plus 2 plus 2, x equals 4. Solution, set, 0, 4. Hands, if you got that by yourself. All right. So, I see some of you already sent that in. All right, let's go to the next one. Here we go. Example 1C, copy that one. 1C. Let me pause this really quick. And it reads, example 1C, absolute value y minus 3, close the absolute value, plus 10 equals 8. Now, some of you are getting distracted elsewhere, so you're going to have a hard time with your home plate with these. And tomorrow's Friday, I'm just giving you a heads up. There's a couple of things that we need to look for, and some of you are missing it. My goodness. So let's do this one together. Line down the equal sign. You circle your absolute value. So like that, you can focus that. You need to get rid of anything outside of that. What's outside of that, everyone? So we subtract 10, subtracts 10. Absolute value, y minus 3. Equals to negative 2. Stop right there. Don't do anything else. Because this one has a red flag. You're like, what? Writing utensils down. Look up to the screen. Let me show you. All right. Let's look at this one. Ready? I'm not going to say anything. I'm just going to point out some stuff. Look up. Let's see. Absolute value by itself with a positive 6, and then it became 2 equations. Okay. Absolute value by itself, a positive 2, and then it became 2 equations. Okay. Question. Earlier when we said about absolute values, how many steps was negative 23 away from 0? Did we say negative 23? So that means absolute values can only be what? So therefore, whenever you encounter an absolute value by itself on one side equal to a negative, get to that point and you're going to write no solution. No solution. You're like, what? Yeah, there's no such thing as negative distances. You know, unless you're in the Superman movie and he goes counterclockwise around the world and then he makes time go back or something like that. Have you guys seen that movie? No? Oh, never mind. Anyways, so far so good, yes? All right. Copy this one. Example 1D. Negative 8 equals absolute value of x plus 2 minus 8. All right, let's do this one together. Here we go. Line down the equal sign. I'm going to circle my absolute value. What's outside the absolute value? Minus 8. So I need to do what? Plus 8 plus 8. And we're left with 0 equals absolute value x plus 2. You're like, that looks weird, Mr. Q. But let's see if we were to follow the process. Is the absolute value by itself? Yes. What would be our next step? Write two equations. Let's see. Let me go back to the previous ones. Look up. Look at this 2. We can write the 2 as a negative 2 and a positive 2 because a 2, or a number that's 2 steps away from 0 is what? Negative 2 and positive 2. Question. Can we write 0 as positive and negative? No. 0 is just 0. So how many equations shall I write? 1. 0 equals x plus 2. Only one equation. Make a note. Put a asterisk, a heart, so you can remember. And then just write only one EQ because of 0. And let's solve. Minus 2 minus 2, negative 2 equals x. Solution set, negative 2. So, from 1 to 5, how comfortable are you up to right there? All right, send me your notes. Hold on, let me for the screen. There it is. All right, not bad, yes? From 1 to 5, how comfortable are you with everything we've seen so far in absolute values? 4, 5, 4, 5, okay. All right, so let's summarize the whole idea to make sure we got all the points. Copy that graph, please. Absolute value. Then underneath, 2 solutions, 1 solution, no solutions. Absolute value, 2 solutions, 1 solution, no solution. So, I'm going to get you started with 2 solutions. Here it goes. Whenever I have the absolute value by itself on one side, and it's equal to a what? A positive number. Whenever it's equal to a positive number, that's when we do how many equations? 2. That's how we get 2 solutions. Let me go to the last one, no solution. When we have the absolute value equal to what? Tell your neighbor. When we have the absolute value equal to what, there's no solution. All right. Brandon, Doherty, when it's equal to what? Very good. When it's equal to a negative number. Whenever it's equal to a negative number, there's no solution because distances are not what? Negatives. That is correct. Last but not least, when the absolute value is equal to what is only one solution? Tell your neighbor, please. Jacob, when the absolute value is equal to what? 0. That is correct. That's when we only write one equation. Did we see all three of them? Yes? So let's move on to the funner ones. Hold on. Yeah, let's move on to a word problem. Woo-wee. Here we go. And it reads, let me pause this really quick. It reads, Sydney Harbor Bridge is 134 meters tall. The height of the bridge can rise or fall 188 millimeters because of the changes in temperature. Write and solve an absolute value equation to find the minimum and maximum height of the bridge. Now, maybe we haven't been to Australia, but some of us have been to San Diego. Have you guys seen the Coronado Bridge? Some of you? Looks kind of like that. Now, most bridges have metal. So think about it. What happens to metal when you put heat to it? It kind of like bends, yes? So that's why the bridge, instead of being like this, it kind of like bends down. However, when it gets cold, it straightens out. So that means the bridge actually rises a little bit. That's what they're trying to say here. So the bridge, check this out, it can either rise or drop depending on the temperature. Not a lot, but enough to make a difference. So engineers, those that design bridges, they need to keep that in consideration. Now, how do we write an absolute value equation for that? So I want you to copy this. Example 2a. Now I want you to write absolute value, x minus, leave that blank, equal to, and leave it blank. So we need to fill this, and we need to fill this. Is that correct? So let me go to the problem at hand. Here it goes. It reads, the Harbor Bridge is 134 meters tall. The height of the bridge can either rise, what does that mean? That it's a positive or a negative of how much? 180 millimeters. So now let me go back to the examples that we did earlier. Look up. Look at this one. Oh, let me go back to the previous one. All right, here it is. Look at this one. Which number became positive and negative? The 6, is that correct? Negative and positive. Okay, so with that said, what number goes here? Talk it over here. What number goes there? Yes? All right, looks like Andrew's got it. Andrew, what number goes there? Yeah, that is correct. Write that in there. 180 millimeters. Why? Because the 180 is the plus and the minus. That's when we do the two equations. So what number shall we write here? Everyone? 134 meters. That is correct. Now, in order to solve this, we're not going to solve it. I just wanted you to set up the equation. In order to solve this, these two have to have the same measurement. Either make this millimeters or make this into meters, which will be 0.18. All right, so with that said, look at this one. Look up to the screen. A support beam on a building, underneath some buildings, they have a support beam, must be 3.5 meters long. Okay. The beam could differ from the ideal length 3 millimeters. Write me an equation for that, please. Write me an equation for that situation. All right. Share with your neighbor, see what you wrote. What is your equation for that? All right. Anthony E., what is our equation? Absolute value x what? $3.5 meters equals to 3 double M. Hands, if you got that? That is correct. That's how we set up our equations. So tonight's home plate, here it goes. Look up to the screen. Fairly simple. Look at them. Pretty straightforward. Okay? So, only 10 pounds for tonight. Have a good one, everyone. Enjoy your home plate. See you guys tomorrow.